at Siemens, and you have some peer-to-peer communication system.
Right. Yeah, what we have here is a peer-to-peer communication system where you have voice chat, video. You can do calls, regular telephone calls. You can make. You have a buddy list.
Yeah.
You can search for users here. As you can see here, you can enter a given name. You can enter the city. You can search for these users, and then no results there.
Yeah. But how about which database does it search on if it's peer-to-peer?
Right. There is no central database or something.
Yeah.
You enter your own profile.
Yeah.
And you give your own name, and you can enter basically whatever you want to. And then this database is like distributed over peers. So that you can have millions of peers, and the database is distributed over those. You don't need a central LDAP database.
Yeah.
Right.
So
and then you can search the database. You can imagine it like you take the large whole database, and you split it in the number of different parts, like the peers are. And each part is on one peer then, and that is searchable basically.
All right. So this peer things you call it?
Yes,
is that
right.
the name?
Right, exactly.
So this software it enables voice.
Right. You have voice. You have you can make video calls.
Yeah.
You can send instant messages.
Yeah.
You can see if someone's online or offline. If it's gray, he's offline. You can even see if he's making a phone call right now. So if he would make a phone call, Tom is on the other side now. Then this telephone will be like
occupied.
Yeah, he's occupied. You can see that he's busy.
Yeah.
So we've got a really exact presence here, which is with a central server kind of hard to reach because you get lots of messages. But because here everything is decentralized, all this load is distributed over all the peers.
All right.
That's basically the idea.
So you don't need to have compared to Jabber system.
Yeah.
There you need to set up servers all over the place.
If you take Jabber example, here it is like each peer is a Jabber server, is his own Jabber server. So you have millions of Jabber servers.
Yeah.
The protocol is not based on Jabber, but you can imagine it like it's similar to Jabber itself.
All right.
It's XML-based protocol, so yeah, it's kind of similar.
Does it have something to do with Cademlia?
Exactly. What we are using is a peer-to-peer protocol called CORD, developed by MIT, or they had the idea. We adapted that so it is practically usable, and it's a distributed hash table. The algorithm is a distributed hash table. That is like Cademlia. Hash table, yeah. And then Cademlia is used by Overnet, which is like Emu, and we're using it here for voice and video.
Cademlia is also using that kind of concept?
Cademlia is kind of like a similar protocol like the one that we are using here.
Yeah?
Right.
Also based on the MIT idea?
No, Cademlia is a development by, I think it is New York University or something like that. Yeah.
So your peer-to-peer system could also be used for file transfers?
Yeah, we can use it. Internally there is a file sharer, but we only use that for distributing updates. Updates, right. So we don't want that public because we want that to sell to carriers, and they don't want illegal stuff on their system because they may get sued or something like that. So,
but is it very good at peer-to-peer file transfers?
Yeah, sure. I mean, you can do everything that you. I mean, it's not integrated into the client, right? So we don't want to do file sharing here. Definitely no file sharing.
But one thing that I think I noticed from Cademlia is sometimes it's slow, no? To find the file, or you have to connect and it takes a while, or...
Yeah. I don't know, maybe it's a problem with Cademlia.
You don't have that problem?
No. I mean, what we have is like, we parallelize everything, and that means that if a client crashes, another one is chosen immediately, or almost immediately. We've got like timeouts from 200 milliseconds, something like that, to parallelize everything. So it's kind of really reliable.
So if you search for somebody by the city, for example,
right,
it doesn't take many milliseconds before you actually have their IP and you can talk with them.
Yeah, we don't show you the IP. It is all internally. No, we don't show you the IP. But I mean, the client itself knows the IP, of course. And it's really fast. Yeah. I mean, we've got a small deployment right here because we've got 5 machines down there, and you cannot run many peers there. So, but then again, even if you have millions of peers, it's rather fast, right?
So your software is proprietary?
It is proprietary. What we do for voice and video calls is standard SIP, so we can interwork with SIP domains, with other SIP domains. We can interwork with the PSTN network. You get a PSTN number. You can be called from outside with a regular analog telephone. So we've got the whole interworking with everything that you can think of at the moment in the SIP domain and in PSTN.
All right. So SIP is also with central servers, no?
Exactly. If you maybe I can show you. I can show you a slide of the architecture. We have it here. So you see, this is the peer-to-peer network, and this is kind of like what is based on the CORD algorithm.
Yeah.
Right, and you've got the PeerThings client, which is the PC client, as we've seen before. We've got home gateways inside.
Yeah.
That is this box here down there, the new development, and there you can connect an analog phone, and you can dial, and the end user doesn't even recognize that there's peer-to-peer behind.
This is a peer-to-peer box.
Exactly, that's a peer-to-peer box. Exactly.
But it's possible to see what is behind the plugs and something.
Yeah, sure. I mean, we have. We've got 4 different LAN connectors, so you can build up your own LAN at home. We've got the WAN connector. We've got a fixed line, 3 fixed line interfaces, so you can connect 3 different analog phones. ADSL, of course, it's an ADSL modem. You can connect USB, hard disks, or printers. So you can do
There's also USB in front.
Yeah, there's also USB in front for the same reason.
So this is like a peer-to-peer set-top box.
Exactly. Yeah, right. That's a peer-to-peer set-top box, basically. But you don't see. All you do is you make calls. You can make phone calls, and you can make phone calls from the PC client. You see if a guy is online or busy at the moment with that box. Right.
So would it be possible to use this box for video?
At the moment, that box is not good enough for video. But we plan to integrate that on our set-top boxes as well.
The same peer technology?
Yes, right. That's a plan currently. And we also want to integrate TV. So we call that peer TV, where
live video.
Exactly, where we want to do streaming of live video. All you need is a DSL connection, and then a webcam, and you can stream to thousands of users.
So you can be yourself a broadcaster of live video.
Exactly.
But so there's like the question is if you're gonna control everything, or if you're gonna kind of let people do whatever they want.
I mean, that's a question of the operator, what you want to do.
Yeah.
Basically, both is possible. I mean, controlling everything is kind of hard. If there are like thousands of people doing streams, someone has to control what they are streaming. So I guess if that technology is accepted, then you can't really control it.
Yeah.
So basically, you are allowed to send everything. That's a project that we will integrate into version 2 of that client.
Yeah.
So you have that capabilities inside with the next version.
But for example, BitTorrent, it has a lot of technology with the downloading the file from different people at the same time. No?
Right.
Do you have something like this?
Yes, I mean, as I said before, we have the streaming one to many.
Oh, yeah.
But that is only okay for smaller videos. So webcam is quite okay. You can stream that to thousands. And what you do there, you send it from one peer to 2 others, and these 2 distribute it to 2 others, to 2 others, and then you get a tree. That's one thing. And the other thing is that you can get live video from something someone else recorded on his hard disk with digital rights management and everything. So and here it is that if some peer crashes that you stream the video from, you take another source. And basically you do all the time, you take 3 different sources, and if one crashes, you choose another third.
Yeah. But so for downloading actually video,
No.
no. I mean, if you had a hard disk on this one, for example, you can connect the external hard disk. Huh?
Yeah. I mean, downloading is fine. We can. And there are already lots of tools for downloading.
Yeah.
And what we want to do is streaming.
Streaming.
Really streaming, right?
So, I mean, you're not thinking so much of if people have a video blog, for example.
Yeah.
And they want to broadcast their channel, and people could like download in advance, and then they can just watch in high definition on the TV or something.
Yeah. I mean, that's one possible application.
Yeah.
That's something that
Like you know,
that may be
feed,
integrated. Sure.
RSS
Yeah,
feeds.
definitely.
You can also broadcast that of a peer-to-peer, so you don't need to host the RSS feed in the central place.
Yes, I mean you can do that already, can't you? You take a BitTorrent tracker, you install that on at your website, and then basically you have that already. You can do that.
Yeah.
So I mean, what we are really interested in, say it again, is streaming. But then again, I mean, you know, RSS is a pretty interesting thing, and maybe we integrate that as well. I like the idea, basically. Yeah.
So you have to combine a proprietary system with the open kind of, because if you don't you don't close it, then people they just break the system, or what happens?
The thing is, there's no open standard or something for that kind of like protocols.
Yeah.
I mean, for file sharing, there's many things are standardized.
Yeah.
But if you take voice or video concerning peer-to-peer, it has to be proprietary at the moment, and no one's really doing. I mean, there's CeBIT peer-to-peer working group or something, but they don't make really good progress at the moment. So,
So are you working with other companies to do this? Is there like a WiMAX forum for the peer-to-peer?
Yeah, I mean there's peer-to-peer zip forum.
Zip forum?
Zip peer-to-peer, yeah. But as I said, they are kind of slow at the moment, and I mean we want to do a product that is working right now and not wait until everything is standardized.
So for example, you take a zip phone and you just connect it to this one?
The zip phone at the moment is connected to a HiQ, to a soft switch. And we show here that we can interwork with existing zip domains, which means that, you know, if you want to do peering between the carriers, you already can do that with that system. Like all the peer-to-peer looks from outside like a zip proxy. You know, the zip proxy gets the call and then searches for the right user and then directly sends the call to the user.
Right.
Okay.
It's very interesting. So basically, what you're doing is like rebuilding the whole internet. What? Peer-to-peer internet.
Yeah. No, not really.
No,
I mean,
not really?
what we do is, you need less or very little central infrastructure here, which means that you can have the same service at a lower cost, and that's really important right now.
Yeah.
And that's the focus here, to reduce the OPEX, to reduce the CAPEX for the carrier, and to at the same time give out the same or even better user experience and user service.
Especially for the video, no? Streaming and all that.
For example.
So that's what you say, that you have a peer-to-peer streaming technology already?
We have that in our labs. I mean, it will take a year or something like that. If we can take maybe the next CeBIT, we can take that to the market. But that's currently planned. That's on the plan. Yeah.
Because have you seen PP Live?
No. What is
they have
that?
this Chinese, but it takes like 5 minutes to buffer.
Oh, all right. No,
like
I don't know that one, but okay.
I don't know.
We are talking about 10 seconds buffer that we have in our labs right now.
All right.
So, I don't know.
Interesting.
Yeah.
All right. Thanks.
All right.